Hello, in this class of LTE planning, we will be studying about various steps of planning that are used. So, the very first step is information collection. So, this information collection we have done in our previous classes, in which we have to take concern of each and every losses in the network as well as dimensioning of the network. Now, next step is in planning is pre-planning. After pre-planning, we have detailed planning. So pre-planning and detailed planning. Then we have last one as cell planning. So under cell planning, now as we are planning a cell, so we have to plan all these parameters which are directly related to cell planning. Now parameters which are related are frequency planning. After frequency planning, we have TA planning. TA planning, then we have PCI planning, and we have PRAJ planning. So we are required to plan all of these parameters. So TA as tracking area, then we have PCI. PCI stands for physical cell identity, and PRAJ stands for physical random access channel. So we are required to plan all of these parameters. So in our planning classes, we have discussed information collection, pre-planning, detailed planning. Now we are left with frequency planning, TA, PCI and PRAJ planning. So let's start with the very first, that means frequency planning. So let's continue with our topic, frequency planning. So in this class of LTE planning, we will study about LTE frequency planning. Frequency planning, that means we require a band, and then accordingly we require to decide the bandwidth. So that means for frequency planning we require a band, and according to the band we require to specify the bandwidth. Now frequency planning, that means you are planning the bandwidth allocated as well as frequency allocated. So we require a mode in this, and that mode is frequency reuse mode. So for reusing the frequency, which is a main factor, as frequency is a limited resource, so we require to plan frequencies accordingly so that minimum frequencies can be utilized best. So we have a mode, and that mode is N multiplied by S multiplied by K, where N is number of E node B's, S is, the letter S is number of cells, or I will write sectors, per E node B, and third one, that means K, which is frequency reuse in E node B. So this is a frequency reuse mode, and these are the basic descriptions of these modes. Now we have a very first mode in this, that means type 1 is 1 cross 3 cross 1. this one, the very first mode, as 1 cross 3 cross 1. Now 1 means 1 E node B, 3 sectors, and 1 is a frequency reuse scheme. Now I will draw a pattern and then we will learn. So these are my total number of cells. So these are required to divide into sectors. So for E node B, that means I'm highlighting only this cell. So here I have one E node B. So this will be my one E node B and 3 sectors. Now I require to give a frequency. So I'm using the same, that means 1, 1, 1, 1, 1, 1. That means according to one E node B, that means as per with the one E node B, we are giving one frequency to radiate in all 3 sectors. So this is a mode, that means 1 cross 3 cross 1 mode. Now second mode, the second mode is 1 cross 3 cross 3 mode. So what is there in 1 cross 3 cross 3? Now we have 3 frequencies for reusing with 1 E node Bs. Again we require to specify 3 sectors. So if this is 1 E node B, 1 E node B, so I have 3 frequencies, 1, 2, 3. So with 1 E node B, I have 3 frequencies, 1, 2 and 3. Oh sorry, with this 1, 2 and 3. So I will allocate frequencies accordingly, because I have for 1 E node B, I have 3 different frequencies. In the previous case, for 1 E node B, I have only 1 frequency. So this is the second mode of 1 cross 3 cross 3. Now third mode is somewhat different. So third mode is 1 cross 1 cross 1. That means 1 E node B, 1 cell and 1 frequency. Now we don't require to divide the sector, we have to give this frequency to the entire cell. So for 1 E node B, 1 frequency to radiate in all directions. So that means for different E node B, you have a frequency, different frequencies, and they are radiating throughout the cell. So this is a mode of 1 cross 1 cross 1. Next we have mode which is 3 cross 3 cross 3. This is a very important mode, that 3 cross 3 cross 3. Now 3 E node Bs. Let's say these are the 3 E node Bs. Then again next are connected Okay. So again I require to draw the three sectors. I have three different E node Bs in one area. So this one is 1, 2 and 3. Three sectors or small cells, and then I have three different frequencies. So how do I allocate? So I will allocate 1, 1, 1, 2, 2, 2, 3, 3 and 3. So different frequencies to different cell. So this is a one way to do this. Otherwise we can say like 1, 2, 3, 4, 5, 6, 7, 8, 9. Different frequencies to different cells. This is also 3 cross 3 cross mode. Next, or the last mode of frequency reuse, 3 cross 1 cross 1. Now 3 E node Bs, 1 cell. No requirement of dividing it into sectors. So I have a 3 E node Bs. So I will give 1, 2 and 3. In that cell, one frequency. So I'm reusing again. That means I am giving 1 again, 2 again and 3 again. So this is my mode of 3 cross 1 of frequency reuse modes, total number of frequency. Now the question is that why we require such reuse modes, because sometimes we have omnidirectional antenna, sometimes we have two directional antenna, sometimes we have E node B connected, or sometimes we have E node B separated, and according to the area, according to the area plan, we require to give the frequency reuse mode as desired. That's why we have a number of frequency reuse modes, and accordingly whatever bandwidth, this 1, 2, 3 are ERFCN numbers as per the bandwidth. Now move to the next topic as intra-frequency networking. Intra-frequency networking. Now let's understand what is intra-frequency networking. All frequency bands can be used in each cell. All frequency bands can be used in each cell to have high frequency efficiency. So I can say that high frequency efficiency high frequency efficiency can be achieved when all frequency band can be used in each cell. So to have. Now how intra-frequency networking can be used. So I will make 3 cells and I will give F1, F1, F1 to the entire cell, and again then if I have more cells I will use F1 mode. So this is the advantage that if I require high frequency efficiency, so I can use all back in each cell so that I can have easy handover. If I am having same frequency, I will get same easy handover and a procedure which is easy scheduling. So this is the concept of intra-frequency handover, as intra means same. So you are giving entire cell the same frequency so that you have high frequency efficiency. You can have easy handover, easy scheduling. So what is the disadvantage? So disadvantage is large interference on the cell edge. That means at this particular areas at the cell edge. So this becomes the disadvantage that at cell edge we will have large interference. So at the cell edges we are having large interference, that means consecutive or difficult for consecutive coverage. So this method is difficult for consecutive coverage. So this becomes the disadvantage of intra-frequency networking. Now where we can use this intra-frequency networking procedures. So that means its usage we can use intra-frequency networking if bandwidth allocated. If the bandwidth allocated to me is greater than equal to 10 megahertz, I'm a operator and I have bandwidth greater than equal to 10 megahertz. So it can be used. That means I can use intra-frequency networking. Can be used for initial network. So it can be used for initial network construction. Initial network construction in urban and densely populated area. But remember, in case of initial network construction, I can use inter-frequency networking for urban and densely populated area. But what happens if my bandwidth is less than 10 megahertz? So I can use this concept in rural and suburban areas. So this is basically, that means I can use suburban and rural areas so that network construction cost will be less. That means to reduce network construction cost. So in short, I can use intra-frequency networking only whenever I have a main focus on initial network connections or initial network cost. So I can use this type of planning concept in urban and densely populated area. But the thing is, I can plan in densely populated and urban area only if I'm getting bandwidth greater than equal to 10 megahertz. That means either I'm getting 10 megahertz, 15 or 20 megahertz. So I can use intra-frequency networking concept in such areas. But if I'm not getting bandwidth greater than 10 megahertz or I'm getting bandwidth less than 10 megahertz, so no, I can use this inter-frequency networking planning concept in rural and suburban areas so that my network construction cost will be less. I can deploy such type of networking rural and suburban areas. This is what about this is the very first step, that means very first type of planning of a frequency in different areas. So in intra-frequency networking, everything is good, is handover, so we can deploy. But the problem is that there is a large interference on the cell edge user. That means we require high level of optimization on a cell edges because user will get continuous problems or continuous interference in the cell edge part. So it will be very easy to have a continuous coverage because here at this end we will receive interference level. So anyhow we will use these by deploying such categories or using in such category areas. So this is all about intra-frequency networking. We will continue in our next class inter-frequency networking and its various types. So this is all about for planning class of today. We will continue in our next class. Thank you so much.